You know that feeling when you sit down at your desk, you type out this incredibly careful prompt, you hit enter, and you just wait.
And then it comes back subtly, just frustratingly wrong.
Exactly. Frustratingly wrong. So you
Yeah.
tweak the wording, you run it again.
Yeah, and then your whole afternoon is just completely gone.
Right. It's this endless, exhausting loop of guessing and checking. Beat. Well, back in June 2026, Peter Steinberger finally called this out.
He's the original creator of OpenClaw, right?
Mm-hmm. He published this viral post about this exact daily frustration, and it quickly pulled over 8 million views online.
Oh, wow. 8 million.
Yeah. He told everyone to stop doing one-line prompting entirely. He basically argued that sitting there manual prompting is a complete dead end.
Which is so true. We should be designing automated agent loops to do the work instead.
Right.
I mean, it really shifted how developers think about their daily automation.
Yeah.
Because we've all been stuck in that exact spot for hours.
Absolutely. So
Yeah.
welcome to this deep dive into the sources today. We are unpacking the mechanics of the agent loop revolution.
We really want to figure out this massive shift in our workflows.
Yeah, we need to step out of the AI driver's seat completely.
We're going to break down what these agent loops actually do technically.
Mm-hmm.
We'll look at why manual prompting quietly traps your time.
Mm-hmm.
And then we'll explore the 3 main setups you can use today.
Plus, we have an absolutely incredible real-world engineering story later. One developer ported 750,000 lines of code, and he basically completed this massive migration while he slept.
That is just staggering to think about.
It really is. Let's start by unpacking the actual mechanics of these systems, though. We all know the deep friction of typing out endless instructions.
Oh, yeah.
So what is the technical system that actually replaces us?
Well, Google engineer Adi Osmani defines this core shift perfectly. It's fundamentally about replacing yourself as the primary prompter.
Right, so you stop feeding instructions to the model one by one.
Exactly. Instead, you build a wrapper system that prompts the model for you.
And it follows a really specific cadence under the hood, right? It uses a reason, act, observe, repeat framework.
Yeah, that's the one.
Let me just define that jargon real quick. The system plans, acts, checks itself, and retries.
Yeah, that automated cycle is the beating heart of it.
Yeah.
It reasons through what logically needs to happen next, then it acts on that formulated plan right away.
And after that, it observes the final output. It checks its own output to see if it worked.
Precisely. But, it completely falls apart without 2 rigid requirements. First, you need a hyper-specific goal for the overall system.
Mm-hmm.
Second, you need a concrete programmatic way to check progress.
Because without a programmatic check, the system just,
Correct.
it drifts completely aimlessly. It reminds me of trying to run a marathon in thick fog.
Without a map.
Right. If there's no visible map or finish line anywhere around you, you just run in circles until you finally collapse from exhaustion.
Yeah, exactly. And the AI does that exact thing with your token balance.
So let me ask you about that specific failure mode. What actually happens if you don't define exactly what done looks like?
Well, under the hood, the model lacks an objective stopping condition. So it just relies on its internal probability, which degrades over time.
I
It will either hallucinate wildly or just abruptly stop working altogether.
So without a strict finish line, the AI just spins its wheels forever.
Exactly. It just burns your compute budget for absolutely no reason.
Knowing that loops require rigid boundaries makes me think deeply. We are still relying heavily on manual workflows in our daily lives.
Yeah, most people are.
Why is that old manual way fundamentally broken from a technical standpoint?
Because large foundation models rarely nail complex logic immediately. Anthropic recently published some fascinating research on this specific problem.
Yeah.
They observed that AI agents operate across many continuous sequential turns.
And small mistakes compound rapidly over those multiple turns.
Yeah, a tiny hallucination becomes a massive cascading error really quickly.
Yeah.
Every AI tool currently available works this exact same way.
It makes its best statistical guess based on your initial instruction.
Right. But a single instruction leaves massive room for major misunderstanding.
Exactly. Getting to something usable usually takes several targeted rounds.
It really does.
I still wrestle with prompt drift myself, honestly. I asked for a script, and 3 prompts later it's ruined. The whole entire architecture is just completely unrecognizable and broken.
I know exactly what you mean.
Manual checking quietly eats up hours of my productive week. You fix one minor thing, and another major thing breaks immediately.
And that's the exact problem these automated loops actually solve. They hand that tedious checking work directly over to this system.
Hmm.
Look at how Claude Code implements its /goal command feature. You literally give it a strict pass-fail condition right up front.
Like telling it that all integration tests must successfully pass.
Precisely. Claude writes the code, but a separate model evaluates it. The evaluator runs tests and feeds the raw errors back to Claude. It tries again without you ever typing a single word manually.
It's like delegating a complex project to a junior intern, but you also hire a senior manager to constantly review things.
Exactly.
That manager checks the intern's work before it reaches you. So the messy early drafts never even reach your actual desk.
That strict separation of duties is the crucial part of this.
But let me deeply push back on that specific architecture. Isn't it incredibly risky to let the AI grade its own homework?
Highly risky, yes.
Yeah.
Which is why the evaluating models are kept distinct. A model assessing its own output suffers from inherent self-affirmation bias.
Right. It likes its own work.
Exactly. It naturally favors the exact text sequences it just finished generating.
Got it. Separating the worker from the checker prevents the AI from getting lazy.
Yep. It keeps the whole system honest.
You know, whenever I look at AI discussions online these days, I see these incredibly wild extremes popping up constantly.
Well, for sure.
Scroll through X or watch a few tech YouTube videos. People constantly brag about running 24/7 autonomous agent fleets online.
Burning massive token amounts just to feel cutting edge.
Yeah, exactly. Or, conversely, they just do absolutely everything completely manually. It makes me feel behind just using a single looping agent.
Right.
Is all that massive complexity actually necessary for our daily work?
Well, Risa Sullivan captured this exact tension perfectly online recently. The internet really wants you to think massive swarms are standard.
It's easy to think anything less means you're falling behind, technically.
Exactly. But Anthropic's own technical documentation pushes back hard on this idea. They emphasize that agents are strictly best for open-ended problems.
So if a task has a predictable path, avoid agents entirely.
Right, you should just use a standard, strict, deterministic workflow. Predefined steps stay much more reliable and are infinitely easier to control.
Because a giant swarm of autonomous agents introduces...
Yeah, incredible latency and cost.
I love pushing back on that pervasive more is better mindset. Larger systems are rarely needed for normal, everyday knowledge work. A bigger setup only makes sense when the work literally never stops. Think of a massive engineering team shipping complex code every day.
Right, where new bugs come in faster than one agent handles.
Exactly. Writing a single article definitely doesn't need fleets of agents.
Yeah.
Using a massive agent swarm to draft a simple email.
It's like using a heavy sledgehammer to crack a tiny peanut.
Right, and you just end up with a completely broken table. It just wastes your valuable time and your compute money.
It really does.
So let's clarify this for our everyday normal workflows. Do I need to build a whole fleet of agents for everyday tasks?
For most of your daily tasks, absolutely not.
Mm-hmm.
A single loop with a clearly defined goal is incredibly capable. It handles everyday jobs beautifully without the massive architectural overhead.
Right, so a single looping agent handles most everyday jobs perfectly fine. Since we know a single loop is usually enough, let's talk about the actual practical blueprints we can build today. What are the 3 common architectural setups we can deploy?
So there are 3 foundational models you really need to understand. Let's break them down simply so anyone can visualize them.
Okay.
The first is what we call the simple solo loop. This is one model doing the generation and checking itself sequentially.
Ah, I see.
It's really great for absolute beginners to start experimenting with.
But we just talked about that dangerous self-affirmation bias issue. A solo loop sounds a lot like editing your own writing.
Yeah, you're completely blind to your own structural typos.
Right. You miss the structural and logical flaws completely.
You nailed the exact critical limitation of that basic setup. And that's exactly why Anthropic strongly recommends the second blueprint instead. We call this the maker-checker loop in the AI industry. You have one agent acting solely as the initial generator.
Okay.
Then you have a second distinct agent acting as the evaluator.
That second evaluator forces the first generator to actually improve. It catches the subtle things the first one completely overlooks.
Precisely.
So what is the third complex blueprint we can use?
The third is the manager with helper agents hierarchical setup. Think of it as a sprawling corporate tree of automated workers.
Let me define that jargon. One boss AI coordinates several worker AIs.
Perfect. So the manager AI actively splits up a massive complex task. It delegates the broken down pieces to different specialized helper agents.
Mm-hmm.
Then it carefully combines the final results back together seamlessly.
Let me challenge that hierarchical setup for a second here. It sounds incredibly powerful, but also fundamentally exhausting to build.
Oh, it is.
Why shouldn't I just jump straight to the manager setup for everything?
Because the financial token burn rate is completely astronomical. Plus, coordinating multiple helpers introduces massive delays and system latency. You wait several minutes for something a solo loop does instantly. You really only need it for massive, highly unpredictable coding projects.
Makes sense. Overcomplicating a basic task just wastes time and processing power.
Totally agree.
I do want to look at those extreme edge cases where complexity makes sense. Let's ground these abstract theories in hard, undeniable technical reality.
Yeah, let's do it.
What happens when these architectures are pushed to their absolute limits? Jared Sumner's recent engineering project is a perfect example of this.
Yeah, he's the brilliant creator of the popular Bun runtime environment.
Yeah.
He used a hyper-advanced maker-checker loop for a massive migration.
Mm-hmm.
He ported Bun's massive core codebase from Zig entirely over to Rust.
2-sec silence. Whoa, I mean, imagine scaling to 750,000 lines of code in just 6 days. That's staggering to think about from a pure engineering perspective.
It really is.
To do that manually would take an entire team many months.
The sheer speed is insane, but
Yeah.
the methodology is truly fascinating. He posted about the entire process on X recently.
Okay.
Dynamic workflows and intense adversarial code review made it practically possible.
Let's deeply unpack how he actually built that courtroom system. He didn't just have one simple checker passively reviewing the code.
No, not at all. One agent carefully rewrote a single file into the new language,
Right.
and then 2 adversarial reviewer agents actively watched the process.
To clarify here, reviewer AIs programmed to actively look for flaws.
Yes, they constantly argue against the generated code, like aggressive lawyers.
So they don't just passively read the generated code output.
Nope. They actively write edge case tests designed to break it completely.
Wow.
Only the genuinely bulletproof bugs that survive both reviewers actually count. That intense adversarial pressure forces the system to produce incredible results.
That's amazing.
After 6 days, 99.8% of Bun's existing test suite passed.
That independent checking mechanism is clearly the architectural secret here.
Exactly. Matt Van Horn recently documented this exact same phenomenon online, too. He published a viral thread called WTF is a Loop Part 2. It pulled over 44,000 views in a single day on X. He cataloged 15 different production-grade loops used by real developers.
Did they all use those real/goal commands that people copy?
Yes, they all relied heavily on strict programmatic verification steps. A genuinely separate check genuinely catches the persistent logical mistakes.
So Sumner essentially built an automated, high-stakes digital courtroom. The writer agent acts as the desperate defense attorney proposing code.
Yeah.
The reviewers act as the ruthless prosecution looking for any flaw. Only the truly bulletproof Claude survives the grueling automated trial.
That's a fantastic and highly accurate analogy for the architecture.
Let me distill this down to the absolute core mechanism. What made Sumner's 6-day rewrite actually succeed where others usually fail?
Well, he designed a system where evaluators were actively and intentionally hostile. They relentlessly hunted for weaknesses and demanded absolute perfection every time.
Right.
So the generator was forced to keep iterating until it delivered.
He made the reviewers actively fight the code, so only real bugs survived. That adversarial success story is amazing. But we need perspective. Loops are not magical spells that fix every single foundational problem.
Oh, definitely not.
Even courtroom-style loops have very real limitations in actual practice. If we deploy these architectures, we must explicitly know their boundaries.
Yeah, that's crucial.
Where do these automated systems actually break down in practice?
Michael Tuszynski made a brilliant observation about this limitation recently. He pointed out that a loop fundamentally cannot fix a flawed methodology.
Meaning, if your initial premise is garbage, the loop just failed.
Exactly. Imagine you give an agent a deeply vague, terrible prompt. You just tell it to write a good post for online.
Right.
There's absolutely no objective pass-fail metric in that vague instruction.
Right.
The loop just burns through your expensive token limits rapidly.
It produces dozens of useless, repetitive drafts for you to read. It multiplies your manual review burden instead of actually reducing it.
Yeah.
The manual review work remains completely on your plate. You still have to read through all of them yourself.
Right.
The manual review work is not removed. It's heavily multiplied. You still have to manually pick the best one out.
We have to emphasize something really important about these tools. Loops only improve things gradually through repeated, highly constrained iterations. They do not magically invent clear thinking or perform magic tricks. A perfectly polished outcome does not just appear instantly from nothing.
Right. They're only worth running in very specific, measurable cases. Checking the final result must be significantly cheaper than doing the work.
Okay.
Fixing a failing test suite fits this exact paradigm perfectly well.
Because the automated testing is incredibly cheap and lightning fast, getting the code right takes real trial and error.
Exactly.
But if the task is a subjective, one-shot creative deal, running more loops just adds cost without adding any real value.
It just completely wastes your valuable time and your money.
Pointing a powerful loop at a fundamentally bad prompt is useless. It's like repeatedly pressing a walk button in traffic.
Yeah, exactly. You can hit that button 50 times in a row aggressively.
Yeah.
It doesn't make the light change any faster for you. It just wastes your own energy and frustrates you even more.
Right. And that is exactly what blind token burning is.
So let me ask you this directly about bad prompts. Can a loop ever save a fundamentally vague instruction?
No, it cannot. A vague instruction inherently lacks a tangible finish line. Without a programmatic definition of success, the system wanders aimlessly. You must give it a clear and highly objective signal.
No, bad instructions just generate dozens of useless drafts you have to read.
Exactly right.
Let's pull all of these fascinating threads together calmly now. The fundamental limit of AI automation is not about raw intelligence. Bigger is definitely not always better when building these automated systems.
Nope. The real secret to the agent loop revolution is defining completion. It's not about building a massive, uncontrollable fleet of autonomous agents.
It's about building rigorous, highly objective finish lines for your AI. You must know exactly when the AI is actually done.
Yeah. Get that right, and absolutely everything else falls into place perfectly. Yeah. Get it wrong, and no clever, expensive setup will save you.
That's a huge fundamental mindset shift for most developers today.
It really is. So here is your actionable takeaway for today's deep dive. Stop planning those elaborate, overly complex architectural builds right now. Pick one specific, highly annoying task you do regularly today. Define exactly how a computer could mathematically measure its ultimate success.
Right.
Figure out exactly how you will know it is finally there. Then let a simple automated loop take it from there.
Start with that single metric and carefully build around it.
Exactly.
But I want to leave you with one final provocative thought. If an agent loop works best when one AI critically challenges another, what happens when we start training models specifically to be the universe's harshest critics rather than helpful assistants? Think about that next time you ask AI to proofread your work. Until next time, stay curious.